Good evening. Good evening, and welcome to another bit of a session. Okay, let me just make sure we're okay. Right, we're coming up. A minute. Good evening. Okay. So, what we up to today? We're continuing with our web server for the time setting. ESP32 web server serving up a time zone. Now we saved it up, we're able to adjust it and save the settings. If you don't know what I'm about, maybe watch this morning's live stream. And what we do now is we've got to attempt to code this into the firmware. So let's open up Visual Studio Code. Let's put that over there a minute. Oh, okay. Yeah, so we're going to have a look in the code. I need to get to the bit what we're after. I'll give you a quick update if you like. So we've got this displays what the configuration setting is set to for the time zone. Basically, from if I log out, you'll see that we can toggle a relay on, impulse a relay, and we want it to go off a time zone. So we'll have a time where it triggers the relay, saves you having a clock, basically. Yeah, a clock. So we can choose what the range is, say 7 days a week, then you can just choose your time slot, whatever you want to happen, so on and so forth. Let's have a slot in the afternoon, 4:30, 1700, that'll do, 17:15. So you do that, you click save, and then it updates all this. At the minute it's changing the variables, but it's not storing it on the... I froze, hang on a second. Yeah, I got a problem with freezing camera. I still haven't changed it. I knew about it, so my bad. Anyway. Right, so we can change it all there, right? So we change it, but it doesn't save it. Now if I come out of there, if I just log out, maybe if I reset the controller, which I'll do now, and that's rebooting, and if I just try and log in again, it'll log in, and also that it's the time zones ahead an hour. So I need to go back to there, and that's it. So you'll see them all back to default. If I click save, it'll just fill them the default in. So that's Monday to Friday. It's filled them in as 0 because I didn't select anything. Okay, and you can select individual. So if I just select Saturday, and if I click on that, it's going to default that as well. Yeah. So you've got the web interface working. We're able to send these parameters to the firmware, but at the minute the firmware isn't saving them. So we need to address that bit. Okay, here we go then. Oh, let's give you an intro to the project. Ready? I'll back in a few seconds. Okay, we're back. Alright then, so let's carry on. So we've got our EEPROM buffer. When my main UPass software sends a time zone over to the controller, or the ESP32, it sends it at a packet at a time, and the packet can send over 8 bytes. Yeah. So I've created a packet for sending a time zone over. So it's 8. Hang on, 1, 2, 3, 4, 5, 6. Sorry, 6. Is that 7? 6. It'll send 6 bytes over. So I mean, we can have a look at the type of. This is a type of. Hang on. Let's peek the type. Right. So it is a structure of the packet it's sending. So we've got a packet of data type day time zone. Okay. It's a struct, but basically you've got your byte. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 bytes. Oh, we've got a few spares there. Look. That's interesting. Why have we got spares? Don't know. Anyway, it must be sending. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so this is the payload basically. We can send payloads of various types. This is the structure for the payload that we're sending. So that byte contains the day time zone. So the information of in memory, because you store more than one time zone. So that tells you which time zone we're talking about when it sends it a data. What else we got here? Yeah. So there is a header that goes with that. Anyway. So I think there's 15 bytes in total in my packets. The 14 bytes plus a checksum to make sure that the data is valid when it gets to the other end. Okay. So we've seen what that is. We're only using part of it. We don't seem to be using the spare parts. So that's weird, isn't it? Anyway, right. So each byte that's sent over. So this data of daytime zone dot time at 0 to 2. It's telling you which part it's sending over. I think it's the hour. Yeah, it's the hour. Is it the hour? Why is that 8 to 12? Yeah. Oh, it just happens to be sending it, doesn't it? So we're sending over each packet. It can put into a buffer, each byte into the buffer with these offsets. Yeah, so that's that byte goes into that base address plus 1. Yeah, so it's just moving along 1. Now that's one lot of data, so how's it getting to the rest of it? I can't remember now. Right, so we're if the daytime zone day zone is equal to the zone day address, event day PM and count as 17. Anyway, wrote this a while ago, long time ago. So set number of time zones, write the EEPROM buffer, send back a packet to acknowledge it, engine command, execute a ping, so it sends a ping back to, and it's also sending back some generic byte for some reason. Zone saved, compare EEPROM buffer with time zone, spare one, what's it doing that? Zone matched, I see. Zone no match, so it's actually read it back as well. Yeah, so okay, whatever that is. Right, there's lots of stuff in here. So we need to leverage this information. This is how we send it. We can reuse this buffer for storing our own data, but this time it's not being sent via a packet from the main software. It's being sent with a web page. That one there. It's being sent via this. Now this is not the same data structure as the way I was sending it. So I need to have a function that converts this data into fills this buffer basically ready for writing. Because once this buffer's filled with the right data in the right order, it'll go down to here and actually go to this function which will write the data to the EEPROM. Spare, oh, it is using spare 1, look at that. It's setting the number of time zones from spare 2, and it's the number of the time zone it's setting as spare 1. Yeah, so okay. So it's using those just for some handshaking. So it's all sent in one packet. So we're reutilising certain things, yeah. So we know what we've got to do. So we've got to get over to the web API, which is over here, and this is the data that's been put into the variables. Now we need a function. So that there will serve up the web. Yeah, so when the credentials are right and you've logged in and it's received the data from the settings time zone, which is this one here. Settings time zone. Click save, you're basically posting data. So it's on a HTTP post. And it's going to loop through the parameters that have been sent via post. It's going to check each parameter. So you've got the for loop that goes for the number of parameters. So that's request param, so that must be returning the count of parameters that were sent. And then it's looking for the parameter name. It's looking for the ID number or the name of the parameter, and if it matches the one that we've stored in our lookup table, it'll copy that into whichever parameter. So the first one's doing the days of the week, which is that one there, that drop down there, and it's looking for days of the week. And if we care to look at what this is, let's peek the definition. You can see it says days of the week. So it's stored in program memory, days of the week, so it's actually looking for that in the P name. So the name part of the thing that's sent back. If you want to see what's sent back, you can have a look here. Right, so where is it? Hang on. Right, here it is. So days of the week, that's the column span. There you go. There must be a selection. Yeah, here's a selection here. See this selection and the options. The ID and name is days of the week, right? So this provides the options, which you can see down here. Okay, and its name is days of week. So you go back into here, and it's comparing the name that's been posted with all the rest of the parameters. It's looking for that one, and if it matches the days of the week, it'll take the value, turn it into a C string, and then put it into days of the week. So storing the value there. Just have a quick watch down here. Yeah, okay. Good evening, everyone. Yeah, so it puts days of the week into there. And the rest of the parameters, honestly, then you've got to do something with days of the week, because all that is a piece of text at the minute. So I've got an if statement, an else if, and an else to process the days of the week, which will be a string that says days of the week. The string will be whichever it'll be the string of, yeah, which one will it be? Days of the week is that value, yeah, so yeah, I'm comparing it now to try to, because I haven't assigned it an ID number or anything, it's done on text, so I'm looking to see if that one that we've just saved into that variable is equal to the one that's stored for Friday. So we have a look at that, peak the definition. It's Monday to Friday, so it's trying to find out if I've selected Monday to Friday, Monday to Thursday, whichever one I've set. These are the settings for the choices. So this drop down, all that represents this drop down option. It's a select drop down with the option. So if I choose Monday to Sunday, it's going to compare with this one. So Monday to Sunday. So it'll go down the list, it'll drop through, and it'll go Monday to Sunday, and then it's going to set days of the week, which is I've defined as a byte. Just peek the definition. It's just a byte, days of the week, right? Because I don't use ints in the control, I use bytes for selection logic. That just goes back to trying to save memory when I used to work off Arduino Mega with, or Arduino Nano or something with not much memory. So I use bytes. I use bytes, but it could just be a T, a Unit 8T thing, but I just use bytes. I think it's the same thing at the end of the day. Right. So we'll choose that. It loads that value. So I've got a struct set up, TZ days of the week struct, and if I do a peek of that one, it'll take you to the struct. So I've created a struct, and it just turns the choices into numbers. That's all. So your struct is so Sunday will be 3. So it's looking for a number 3. So it's turning the text of Monday to Sunday into a 3, and that gets used later on down the bottom. And then it'll carry on. This for loop will carry on running. It'll keep doing an if statement to select. See if it can select the next parameter. It's going to check what hour 1 is and load it into hour 1 on hour 1 and so on, all the way down the list. So what that is doing, it's loading these drop down combos here. I'd say combo, but it's in HTML it's select and then you got the option. So it's reading. Say if I go, let's just go back up. So if I go to this one, zone on hour 1, if I just peek the definition, you'll see it says on hour 1. Right, so it's looking for that. If the name is on hour 1, the name that's been posted, one of the parameters been posted, if it's on hour 1, it'll put that value into on hour 1, which that's a variable, and that'll get used at the end. It does it, or it goes through and does them all. So it's basically loading these variables in these selections, these select options into these. So you've got 1, 2, 3, 4, 8 different variables plus the day of the week select. So that ends you've got 1, 2, 3, 4, 5, 6, 7, 8. So that takes all those variables that you've sent over with post, HTTP post. So I'll set it up as a form. It's basically a form. If you look at the HTML, it's a form. See that there, form. And the form action is settings time zone. The method's post, and you'll have you've got a table set up there with all the variables that get loaded. It's the end of the form, but you've got a submit button. So your main button your role is a button, and it's for submitting a form, which is this button here. So you're submitting that. Once you submit that, it then comes over to this function, this server routine. Once it gets a post, it comes to this. That's how we're getting those parameters through to the ESP32. Anyway, so once we read all the variables in that we've sent, they get put into these temporary variables. Let me just show you them. Alright, so here I've got some temporary variables, okay, and there are eight variables, and they've got some default parameters in. So when you first refresh your web page, it'll automatically load those variables. Actually, it doesn't. So I told you, yeah. No, it doesn't use that parameter there. I've just loaded a value in while I was debugging. But the variables that get loaded are these ones here. There's an entry for basically all days of the Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. So you've got for Saturday you've got an on time, an off time, and then a second slot of on time and off time. So anyway, that gets used over there. So then we go to check whether we've logged in and the user has logged in. Okay, that just stops people being able to go straight to the page without logging in. And then what we do is we do a switch statement. So we're using that same struct again. So if it's Monday to Friday, which that equates to a 0, there it is as your struct. Just going through the list, okay. So if it's Monday to Friday, we'll take all the variables that have been loaded already. No, it'll take the hour on and the hour off for these variables here that has been set. It'll take them and take the hour, put a colon, and then the minute into Monday time slot 1, and if it's a 1, it's the on period. If it's a 0, it's the off period, and so forth. Anyway, so we do all that, and so Monday to Friday, you'll have to include Monday to Friday's variables to be loaded. So basically, all Monday to Friday. If you've chose Monday to Friday, you'll get Monday to Fridays, the same variables being used there throughout. See that? So you're basically copying anything that was set from Monday to Friday. Yeah, you're copying the form that was loaded, all this data here, whatever you put in there, you're making it equal Monday to Friday. Now you can show that in action if you want. I'll show you that in action. Right, so let's just choose some. Let's choose Monday. Let's just choose Monday to Friday. Monday to Friday. Okay. I'll tell you what. Let's clear it all first. So I'll just save that. We'll clear them all. They've all gone back to 6 o'clock. Now do them again. Yeah. Hang on. Go Monday to Sunday. Clear. So they're all back to 0. So this defaults back to Monday to Friday. So we're going to do Monday to Friday. So let's just show you what happens. So 9 o'clock, 9:15 on, off at 10 o'clock. Yeah, that'll do. Say 10:30. Then the second time slot is 5 o'clock or 5:45 to 6:15. Yeah. Okay. So we've done that. And because we've got Monday to Friday and we've defaulted them to 0, we click save. It's only going to change Monday to Friday. It's left the others as it is. Say if Saturday I wanted to do one for Saturday, I'll just go there and I'll just select 9 o'clock till 9:30 till 10 o'clock, and I'll just save for Saturday, and it'll just update that one and leave the rest where they are. Okay, so excuse me. So that goes back into here. So if it's just for Saturday, like I just set, that's Monday to Saturday. If I just go down the list, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So you can see I'm only copying what was sent into the Saturday. So that's how it does that. Right. So anyway, we're just handling the request. We're sending the web page back with the same processor. So when it gets to there and you've submitted your button and you click save, it's just refreshing, sending that request back. So sending that web page back. So we've got our data into our variables, right? So if you wonder which variables are there, I'll show you again. These variables here. So they're loaded, ready with the variables. But they're no good as variables there, okay? Because they're string values, okay? So we've created string values from it. But we don't need string values. What we need is bytes. Okay? And the bytes have to fill this EEPROM buffer. They don't have to, but that's an easier way of doing it. You've got various. Let's have a look at the routine that saves them. Hang on. So this time zones EEPROM write buffer. I go to that routine. Right, this is the routine that writes the buffer to the EEPROM memory. Writes it in bytes. But we've got to convert a string, a time as a string, into equivalent of bits that go, or bytes that go into. First, it's got to go to bits, then convert to bytes. So you've got to have a way of turning the time into bits. So that'll have to be probably some kind of lookup table or something, or formula or algorithm. So let's just see if there's any other way of saving this time zone out. So we're writing the whole buffer there. I'm sure you can load the read buffer. You can load it from the buffer. You can write the buffer. I'm sure you can get the number of time zones from the system. We don't need that because we're only going to use the one. Set number of time zones. Right, now, is there another way of writing? I think you have to write the buffer, if I remember right. I can compare the EEPROM buffer with the time zone. So there's a compare. I can get parameter, get number of zones, get EEPROM zone offset for time zone. Alright, so yeah, because I think we can store 10 time zones. We've got the memory to store 10 time zones. So we're not using them, so we don't need that function in this particular case. And there is no other function for doing anything other than writing from the buffer. So we need to fill the buffer up with the equivalent. Now if you look at the buffer, let me find the buffer size. Yeah, the buffer size is 108 bytes. So by EEPROM buffer is number of bytes, time zone, 108 bytes. Buffer for receive bytes queued to write the EEPROM. Okay. And the reason we got a buffer and we're not writing a packet at a time is because while we're handshaking with the data being sent, because it'll send I forget how many packets of data it sends them over a packet at a time. Yeah, it does 2 hours worth on each packet. So to send a whole day or a whole week, you got to handshake a few packets. quite a few packets. You can easily work it out. Anyway, so that's why we write it into a buffer, because we don't want to start writing to the EEPROM. That slows down the system. We don't want to write to the EEPROM while we're receiving data, packets of data. We want to receive the packets, put it into a buffer. When the last packet is received, then we want to write it to when the last packet's received. So it gets all this, keeps sending the buffer packet of data, and it translates it into, it takes it down, it's adding to the buffer as it goes. This daytime zone is being incremented from the main software, so it keeps track and it waits, it'll send the next lot of data, so it'll never overwrite the same memory location. Basically, that's how it gets to the end. So what it does, it'll have to do a compare here, end of the transfer beep. So it's going to check the daytime zone is equal zone address event day PM. So if it's equal to event day PM, so the event day PM, if we have a look at that, peek the definition, yeah, it's 102 to 107. It's actually not though. Yeah, it is, I think. Yeah, there's 100 and starts from 0 base, so it's basically checking to see if the last packet of data has come in, and the last one will be event day PM, and it's the last address space for the packets of data. So you've got 2 to 107, so there's 5, should be 5 lots of data. 1, 2, 3, 4, 5, 6. So you've got 6 lots of data. Yeah, so yeah. I think I got that wrong actually. Let's have a look. Peak. So it does 6 packets a day from 2 is one of them. It goes to 7. So 2, 3, 4, 5, 6, 7. Yeah, so it will actually send 6 bytes to this address. So that's why it's 6. There's 6 locks going at a time. So 6 bytes of data. In each byte, there's a bit that's on or off, saying whether the 15-minute period in that area of the time zone is on or off. Anyway, right. So we're looking if the count is equal to 17. Count the equals a daytime zone, Monday to Sunday plus holiday plus event. Yeah. Alright, so we must be incrementing this. Count equals 0. Time zones. Transfer is succeeded, so save the number of time zones. Okay, so it'll update the time zones, and it'll write the buffer, and that'll be the offset address for using a spare byte on the packet to tell it where to start writing the address. So when it's finished, it'll send a packet back, an engine command back to the main software, which is a ping command, and there's also a byte being used to send some feedback. I'm not sure what that's for, but some kind of acknowledgement. You can find out what that does if you wanted to go back, but you'd have to check wherever that's been packet is going to, destination packet. So it's an engine command, and it's ping, yeah. So I don't know what that is. Doesn't really matter. Anyway, so that's the way we're doing it at the minute. We're getting our time zone over to the ESP32 or any of the Atmel, whichever device we're talking to. Okay. Let's just go back to this EEPROM buffer. I need to go and have a look at that a minute. EEPROM, so right, it's going to go and write the packet. EEPROM write, yeah, so it is going to go straight to there. I did have a different EEPROM write routine for writing to. Used to store this. I'd store it in one place now. So this EEPROM write byte. This was for writing to a spare I2C memory RAM. I forgot what they call it now. It's just a memory chip that was on a precision real-time clock. I was using that to store it on initially, but we've abandoned that because we don't always have a real-time clock and a spare memory chip. So we're now writing it to. You can look where it goes to. You can look at the number of time zones. So the zone offset, right? So if we peak that one, yeah. So this is the memory offset for where we're storing the time zone, which is quite high up. I've got all the EEPROM memory configuration set out. So right, these are the old one. These are the old offsets that used to be in the storage of the EEPROMs. Sorry, the precision real-time clocks. Let's have a look down here. Good evening, everyone. Welcome to Dave Jones live stream. Just doing some ESP32 web interface to set a time zone up. And this main firmware is already working with, let's just bring it up a minute, the UPass software.
Welcome to UPass. Engine 22 is now online. Engine 23 is now online.
We're going to go on to the time zone, so let's just expand this a minute. So this is how we do it at the minute. Right, so this is what we got at the minute. Let's just move that out of the way. Right, so we've got this is our main software, and this is our for the working hours time zone, and this is our way of inputting it manually into the web interface instead of using the main software. So we've got our time zone set up, but the way this does, it sends, when I click save, actually let's just click save now, yeah. Let's click save, I've done this morning. Basically if I click save now, you should see the packets going out. Yeah. So you've got your bleep back, and it tells you that both controllers received the packets of data. Anyway, let's get rid of that. So let's get rid of that.
Thank you for using UPass.
But that is using that what got sent via this command. Here's my commands and control protocol. It's sending this command. Send a daytime zone. It's filling the buffer up, so you saw it in action then. It was transmitting to this part of the command and control protocol. It was filling in the buffer with these bytes. Now the program, it stores them as bytes, but in the main software, but in this to save space, it's packing them into a byte. Each bit of there's 8 bits in a byte, and each bit it represents a one of the 15-minute locations. So we've got to create. We've already got this function, the EEPROM buffer in the system already taking up space. We've already got ability to write the buffer. Where's it gone? Up here? No, down here. Yeah, the EEPROM write the buffer once we've got the buffer filled. So we just tell it what zone it is. That'll be a zone offset. So it can write the buffer. So we've got those two functions there ready. But what we haven't got is, because we're sending, normally we'd send it over from the software, the main UPass software. We'd send it over already formatted as bytes, ready to be stored, basically. Yeah, that's basically what we do. Now, when it comes to reading that to see if it needs to be on, that's an old kettle of fish, different story. But we'd have to go down to time zones. Oh, that's our time zone there. That's for storing our time zone. But when we come to read, I can't remember where it is now. It's somewhere around there. The big program. So it'll be processing the something or other. I can't remember. Let's have a look in main. Let's have a look in the main. Can't remember where it is now. It'll be in the main loop. So what we've got here: input check switch on, outputs checked, timeout. Don't know if it's in outputs or it's in here somewhere. Check, scan the RFID, and it also might be in these outputs. Check, timeout. Let's have a look at there. Can't remember now. Output enables. No, it's not in that bit. So it's, where is it done? Is it done as part of the scan RFID? Checked in. Check switched on. Inputs check. Can't remember where I did it now. That's funny. Check display update. Is it part of that? No. Oh yes, yeah it is. Yeah, I've put it in, incorporated it into display because it's an outputs to display. So we've got check time zone, check daylight saving. Yeah, it's got. So if we check the time zone, that'll be it. So go to definition. It's in the dual timer part. So we've got a function called check time zone. It's looking at each controller can have two timers. So if it's timer 1, if the state is on, or timer 2, then it'll do this. If they're switched off, it won't bother. Checks the timer action. It's got to be greater than 0. If the on action is set to nothing, it won't bother doing anything. Right, so it's going to check the timer time zone is greater than 0. It's got to select the time zone. Yeah, and it's going to get the minute. What's that going to do? By get minute, yeah. So it's going to get the current minute, and because it's doing this every second, like, so it's going as if the minute is on. It only checks to see if it's on the hour. If the stored data for the time zone is on the on the 0 minute or the 15 minute or the 30 minute or the 45 minute, because it's every 15 minutes. And we're going to do a check now. It has to do a check. Check if bit is on now. Right, so it's going to check. It's going to send the time to this function. Let's see what that's got. Go to that definition. So check if bit is on now. You've got to send it the minute. Bool, this is from access group. So it's not from an access group. The byte is the zone, so it tells you which zone to look at. This is where I was trying to find the public holiday stuff that was built in last time. So data check is 7 or event day 8. So we've got normal 0 to 6 for the 7 days of the week, and then we've extended it to 7 and 8 to do public holiday or a data check event day. So we're gonna have, it's gonna get the byte. So switch the date to check if the zone day address equals AM. Right, so get hour is less than 12. Yeah, so it's gonna do, yeah, what it's doing, if the hour to check is less than get hour. Right, where's it getting that from? Oh, getting the current hour now. If it's less than 12, it'll take the address time zone from the AM. If it's, because you start from 0 to 11 for, 12 o'clock at night till 11, 12 in the day. Otherwise, it'll pick the address up front, make the zone address equal to this one here. Let's just see if that has a value. Yeah. So use your zone addresses. So this is telling you where it's going to pick it up from. So we might need to use this actually. Yeah, might be able to use some of this that's already there to. Yeah, this is our address offsets basically where they're stored. So the AM will start at offset 12 in the buffer or the memory location, and that ends with event day PM. Right, anyway, it's quite a complicated thing, but it does work out. So that's getting the offset in the memory where, yeah, so that's all doing that for you. It's all very well. Right, then you got your minute. Okay, so your bit position as well. So your bit position in your byte. So bit position. So am I using 4 bits or am I using 8 bits out of a byte? Can't remember now. So hang on. So bit position will be 0. So you've got 0 the hour, quarter past, half past, and quarter to the hour. There's your bit positions within the data that it needs to extract to see if the bit is on. Yeah. Right, if it's not from an access group, this timer 2. Check timer 1, timer 2. We'll return the results or whatever that is. Get byte offset from address from now hour. Right. There's all sorts of stuff going on here. Hang on. Yeah. So basically this is going to return something. Return a bool. It's going to check if the bit is on. So it's going to look in the right place where the zone needs to be on. If the bit is on, it'll return a bool. Okay. And it's obviously going to check the minute. That'll be false normally, and this is going to be the zone. So it's going to check the memory location that's stored. So zone day address, yeah. How's it doing that then? Data check. It's switching the data check. So the date, where's that being used? So switching data check. So it can choose day of the week. Alright, and then it's switching the minute. So where does this use though? So zone address and bit position is used somewhere. Right, here it is. So bit read, it looks like a multi-dimensional array of some sort. Bit read equals time zone -1 plus the zone address plus the byte. Get the byte offset address from the now hour. Oh my god, this is crazy, isn't it? Anyway, so it does all that, and then it checks if the bit read, byte to read, get bit offset from now hour, plus the bit position is equal to 1. If it's 1, else do this one. So dual timer is active is true. Display update device status. Execute the action. Packet on output on. So execute action of on action on number. So it's going to switch on the relay basically. And if the bit is not equal to 1, it's going to do the off action. So it's going to do off whatever was detailed in the off action. Yeah. Update status. Dual timer 1 is active is false, and it'll reproduce the same code for timer 2 as well. Yeah. So it does all that for you. So that's the way it reads it. But yeah, I'm just looking at this now. Am I only using 4 bits of the byte? I thought I was using all 8 bits. That's interesting. How was I doing that then? So doing the hour. I don't know. I can't remember how I'm storing this now. Hang on. It's got to be able to see it. So you've got your minute. So check if bit on now. So your group and your minute. Right. So it checks if it doesn't have to send in. It sends the minute. So it's only sending the minute. Is there a back? Right. Yeah. So check if bit on now 0, bit 15. That's the minute. 30. Yeah. And it's not even using the bool, is it? Let's go back to it. That's not even using the bool. It can return a bool. I must be using it somewhere else. Where am I using that then? Why have I got a bool if I'm not using it? I'm not doing a check. Not loading it. So it's doing that for... Anyway, this was written a while ago. About 6-7 years ago now, so... Retard the minute to check if between... Yeah, so it's only if it's just loaded. Yeah, there's all sorts going on here. So check if bit on now. So I'll tell you what we'll do. We'll find... Yeah, so we're only checking. Maybe I'm not using all the memory. Let's just let's find all references. See how many of these it finds. See if any of the bool return values been. Oh yeah, no, that's the actual thing itself. Dual timer source. Oh, that's just the yeah, access groups. Ah, here we go. Result access groups. So I must be using the access group. Check if bit on now. Right, that's weird. So we are using the bool back. Get minute. Check time zone. It's part of the access group as well. Alright. Can't remember this. So must have been using the other 4 bits and the byte for something else. So check if bit on now 0. Oh, true. That makes it true. So it knows we're checking an access group. Well, let's go back to that. So that will be true. So from axis group. So we're going down here. Let's find the from axis group bit. If not from an axis group, which it isn't, it does this bit. Now, else if it's from an axis group, it does this byte to read is time zone. Get byte offset from now hour. So something clever going on here. Right, so zone address. Right, let me see what the get byte offset for now hour. From now hour. Let's see what that's going to bring us back. Byte offset from now hour. Well, see, it's right here. Look. So the offset is get hour. So whatever hour it is now, if it'll get an offset. 0, 1, 2, 3, 4, 5. Oh, and 0, 1, 2, 3, 4, 5. Alright, let's get an offset. Get bit off from now hour. This is craziness stuff, isn't it? Get hour. Right, anyway, it does work, so I must have been deeply in a trance when I wrote this. Yeah, must have been engrossed deeply, because it's the work of some kind of either genius or madman. Yeah, it's crazy stuff. Right, let's just check whether I've got audio. Yeah, we've got audio. Right, okay. Yeah. Anyway, I don't touch it because it works. I proved it works. Everything works. So all I'm trying to do is find out. I still don't know whether we're using all these bits. If byte to read is time zone, get the byte offset from now hour. Yeah. If bit byte to read, get the bit offset from now hour plus the bit position is equal to 1, return true. Else return false. Anyway, I know, unless I'm sending, maybe I'm sending in a byte 2 hours worth. That's only 4 bits, so must be, yeah, so I can probably get the byte offset from now hour. So yeah, depending on the hour it is now, it's going to get the offset. And that's in 4, 0 to 4, 05, 0 to 5. Anyway, I've forgotten, so I've forgotten. I try to make my functions more as descriptive as possible without too many comments. Anyway, so it is working, but what I need to do now, well, that's a bit of crucial info. I tell you what, let's bring up the UPass program. We'll have a look in here. Because this sends it over and it'll do it it'll tell me how it's doing it. It's done from both ends. Right. Anyway, so this is the UPass project, the code. So we're going to request to send a time zone, and we've got sending it to the packet. We're creating a load of time zone, 864 bytes of buffer, because we're on our desktop computer. We're not worried about compressing it at this point. We can, in fact, if you get the calculator up, let's just get the calculator up. Let's just try this. So 864 divided by 8. Is it 8? Yeah, 8 equals 108 bytes. So, because we've got 108 bytes with bits in them used. We're not using bits here, we're using bytes to store the same value. So a bit that's on is just in a byte for some reason. And then we have to convert it and compress them. So we're loading the time zone from a blob, a database blob. We can set the number of time zones. Right, if the total length, we're checking the length is 864 bytes long that we've loaded in. But we've told that as a fixed length. Then, oh no. So yeah, we've reserved a fixed memory, but we've loaded it in. So I thought that would always be the same size anyway. But that could make that equal whatever this size is going to give it. Yeah. So we're checking it to see if it's the right size, and then we're gonna do for each B or in loaded time zone. So we're going to iterate through the byte because it stores it in the byte. We're not bothered about desktop computers saving the memory. We're not store it in bits. We store it in bytes. But it gets sent over to the ESP32 and stores it in bits. So we've got this bit here. So we've got a bit of comments going on here. Extract 8 bytes at a time. Right, so what we need to do, we're queuing a packet of daytime zone type, and we're broadcasting the packet, and we're the command or the command and control is a send daytime zone. And now we're going to convert the byte. We're converting the byte of. Alright, so we're converting to a byte in there. This is already it's a zone. What is that? Let's have a look what that is. Peak definition. Right, so it's an enum of zone address. I did use enums going back a bit. Right, yeah. So zone address. We've got an enum of AM, PM, and these offsets in there. Right. So we're storing the whole of AM, Monday AM, in 6. Then we're doing the rest in. Don't know what we're doing here anyway. Right, so we've got the zone address for AM. So we're sending over the location of what we're dealing with. We're sending a packet a day, and this is telling it what the data represents. Then we're sending some filler. We've got a bit of filler going on of 0. So we've got 4 spare bytes that we're not using because we're only using 6 out of the 11. So 6 and 4. Actually, there's one missing there. Oh no, because we're using 1 here. See that? We're using 1 byte there. So 6 and 5 is 11. So we've got a total bytes of 11 in the payload. Now this is the bit where it get byte from array of 8 bytes at the loaded zone at 0. Right, so this is where it's going to extract. Let's have a look what that does there. So go peak definition. Right, so it does get byte from array of 8 bytes. So you put your array in, and this is your offset where you're extracting the bytes from. So it's returning a byte. Okay, so you're putting an array of bytes in and returning a byte. Your bytes out is bytes out. Right, yeah. So it's buffer block copy bytes in, extract from position bytes out. So it's basically using this offset, sending the bytes, which is the whole of the 800 and something bytes. It's got its extract from position. It's gonna set up a temporary buffer of 8 bytes, and it's going to copy from the extract position with the array of bytes coming in, 800 and some bytes. Going to go to the extract position. It's going to put it into bytes out, copy the block from there to bytes out. This is telling it some, don't know what's that give us, array, source, offset, distance or destination, and destination offset, which is 0, and the count is 8. So we're fixed there. We're offsetting, is that saying destination offset? So we're copying it straight out to the 0, the start of this 8 byte array, and we're going 8, what's that say, count 8 bytes, which we're extracting. Right, so once we've extracted from that 800 and whatever it was bytes into the 8 bytes with this, then we combine the 8 bytes into a byte. So we're turning the array of 8 bytes into a single byte. So here's the function, right here, what it does. We're going to return a byte from array of bytes, 8 bytes basically. We're doing a bit, some kind of bit manipulation here, so bit equals new bit. Alright, we'll go for byte, for each byte in bytes in, which is the 8 bytes. If b equals 1, alright, so if b equals 1, what? Index plus plus. So it's if the byte is 1, so if the byte it's read in, one of the first of the 8 bytes is 1, it's going to do this. Alright, so switch the index. So the index, it must be incrementing an index down here, plus plus. So yeah, I don't know whether I scanned for this or whether I made this myself. I don't do C. This is C sharp, by the way. I don't do C where we use a lot of the black magic code. As you can see, it's very simple and basic stuff. I don't want to look at stuff and not understand what's going on years later. But you got ChatGPT now, so you can ask it stuff if you want to. Anyway, I've been streaming for an hour and 10 minutes. Good, no drop frames, touch wood. Camera hasn't froze, touch wood. So anyway, so what we're doing is we're combining the 8 bytes. So let's see what it does for each byte position in the 8 bytes. If the byte is 1, switch the index. So the index will start at 0. Result is plus equals bit dot 0. Okay, so what is result is a byte. So I'm adding bit 0. So yeah, this must have a bit thing in C sharp. I haven't got that kind of thing in the ESP Arduino core. Probably may have something. So it's building up the byte based on the index, and the index is incremented each loop. So it's just a way of tracking it through through to the 8th byte, and it's doing a plus equals a bit 1, bit 2, bit 3, bit 4, bit 5. But it's only if the bit equals 1. So this is a way of setting the bit to 1. So I don't know if I need to go this far. Yeah, I do. I need an equivalent function in the ESP32. I can do a bitwise operator to check if the I can check if it's on, how to create one. Yeah, I'm going to have to do a bit of chat GPT on that one. So that's basically, so this array, if the bit is on in the byte, it'll be a 1. If it's not, it'll be a 0. Leave it as 0. Because the new bytes, as it creates the new byte, hang on, bit is new bit. So, oh, the result, yeah. The result is 0 byte. Yeah, so it's only going to return 1 byte, so it's only creating 1 byte, but it's adding to the bit. So that's something like you could do that, because it must be doing it. Yeah, it's another way of doing it. Anyway, then it returns the result, so it's converting the 8 byte array into a byte. Quite handy if you want to compress and save space. Not so sure I want to do that anymore, but the problem is I don't want to use up. That's the way it's working. What I don't want to do is store in my ESP32, take up nearly 1K of memory, of EEPROM space, 864 bytes. So at the minute I can store that in 108 bytes. What normally would, you know what I mean? I don't want to use that space. But if I did convert it in the future, that would give me up. At the minute, I can only tell you whether the time zone's on or off by the bit. But if I had a byte, I could add attributes to it. Instead of just the time zone could, when it goes on and off, it could do different things. But anyway, I'm not bothered about that minute, not using that, so it's just something to be aware of. Right. Okay, so we've got that. So we basically, we need to follow some of this code. So go back to the Visual Studio Code. So it looks like I still can't work out. Must be something to do with the hour. Can't. Yeah. So going back to this one. We know this one. We know we're sending. We're getting 8 bytes from this thing, and we're putting the value. And as we get it, it's converting it to a byte, converting the 8 bits into a byte based on if the bits are on or off. Basically, if the byte is on or off, it's turning it, it's sending it over, byte at a time. But it looks like I may not be using 4 of the bits. Can't remember. So unless we've got AM and PM. So how many entries we got for AM? We've got 1, 2, 3, 4, 5, 6. So we've got 6 entries for the AM. So that probably tells us what we want to know. So if we go back to, let's go back to the time zone. Let's just run that up a minute. Hang on. That's not it. Let's just run this up and have a look at the time zone segments. We can work out whether we're using all 4 bits, all 8 bits, or just 4 bits.
Welcome to UPass. Engine 22 is now online. Engine 23 is now online.
Right, let's go on to our time. Not that one, don't want that one. This one. Right, let's have a look here. So the Monday AM, so you've got 4, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, so we've got 12 different segments. Well, 12 different sections, each with 4. So I'll get the calculator back up again. Right, so we've got 12 segments, so it's 12 times 4 equals 48. 48 divided by 8 equals 6. Right. Yeah, so we've got 48 different ons and offs bits that we need, and we're sending 6 bytes at a time, so they're all used basically. That's okay, I didn't know whether I was only using 4 bits, but they're all used. So in 6 bytes of data I can represent a whole day. Oh, actually, no, hang on. Yeah, 6 bytes, so it's 12 bytes of data for the whole day then, because I'm sending over, yeah, I'm doing the AM and the PM separately. So there's six bytes for each part of the day. So 2 AM and PM. Yeah. So let's go back over to there a minute. Right. Yeah, so I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 24. Let's get the calculator back up. 24. So we've got 24 divided by 4. 96. Yeah. So we've got 96 different bits that need to be on or off. And if you divide that by 8, 12. There's you got your AM 6 bytes, and you got your 6 for your PM. So there's 12 bytes needed to be for each day. So if you go 1, 2, so you got 1, 2, 3, 4, 5, 6, 7. You got 7. So if you times it by 7, is 84 to cover Monday to Sunday. And I've also programmed in a holiday day and an event day. So you got to go plus another 24 is 108. That's where you get your 108. So it's 108 bytes to store all that lot of data. That's why I limited it to 15-minute periods. So you can click in there and you can shrink it down to that one. That's your lowest bit. So you could have effectively, what happens is if we make that bigger, you've got an on period and an off. But what the software does, it'll look on the hour, quarter past the hour, half past the hour, and quarter to the hour, and it'll reissue the same command. So if your time is kicked in, okay, so if your time is kicked in, let's just have a look at that. So let's close that. Close that. Toggled off. Alright, so my time is just kicked out there anyway, so toggled off. So what happens is, let's close this. So
thank you for using UPass.
Basically I've got lost. Yeah. So that's it, sending the packets of data for each part of the 2 bits for each, 2 packets for each day. Total so many packets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 packets of data to send over the date, but we are not using some of the capability there. We've got 4 bytes not doing anything. I probably did that because I was keeping it simple. But on the last one, we do send over, in the first 2 spare bytes, we're using to send in the zone ID number and the total number of zones. So we're writing on that last byte, we're using it to tell the system, tell the firmware that how many zones we got and whatever. Right, so that's that. So what we've got to do then, we've got a better idea now what we need to do. Still confused about that, but bit position. Anyway, won't bother to go into too detail. Right. So we've got to create a function to convert. Should we ask ChatGPT how to do this? Let's ask it. Right. So let's go on to ChatGPT. Oh, I must have closed it down. Let me just open another version of this. I don't know why I closed that down. Must have gone off it. Right. Okay, so we've got ChatGPT up here. And I'm going to ask it to create me. I need a Arduino C function. I'm going to say C++ because it might give me an old school C. Right, how am I going to do this? I can't directly convert a string of a date and time. I need a lookup table. It's not going to be able to answer this, is it? So what I need to do is, I need to get, I need to first find a start duration. So let's go back to this to make some sense of it. So we've got an on time, say 8:15, and the off time. So this creates your segment for you. So that's 45 minutes of being on. Okay. So I need a function that works out the offset for the 8. So it needs to turn this into digits for a start. I don't have advanced functions like I do in C# where I can work at the time span out from a time. So it's not the right thing we're looking at. So I'm going to have to create my own function to doing this. So we're going to have to what we need to do is we'll need to use this number, turn this text into a number first, and that one. Keep it in a variable, and then the off time. Or do we just... Yeah, we need to turn the bits on. When we click save, we'll have all the bits off. Hang on. Oh. It's probably just reloaded, hang on. Gotta log in again, right, so... Yeah, so anyway, let's just have a quick look out here. Yeah, we had a few visitors earlier on, but they've all gone off. It's getting late. So anyway, we need to convert. We need to know the offset because we know all the other ones are going to be off except for these, whatever we set here. Yeah. So we need to go ahead and if we selected all of them, we need to select all of them. If we've just selected one date, we only need to put those bits on, regardless of what the other bits are doing. We need to wipe them though for that certain area. There's a little bit to do on this because the way we're doing it's slightly different. We're storing it in the same place, but we're doing it in a different way. Anyway, let's give us a better idea. We can't really ask ChatGPT something because it doesn't understand what kind of structure I'm after. If I say convert a string time into a bit pattern, a bit on or off, it ain't gonna have a clue what I'm talking about. a string time on and off for the duration. It ain't gonna have no clue what the hell I'm talking about. To create a function that converts a time duration into a sequence of bits represents on and off state, you can use the millis function to keep track of time. So it has no clue what I'm talking about. Yeah, now time example, run the time to bits function for 10 seconds. Time to bits. What the hell is it? The output time to bits takes 3 parameter duration, total time to run the sequence, on time, off time. Inside the loop function, the time to bits function is called with a 10-second duration, 1 second on time. So it totally doesn't understand what I'm trying to do, and it can't do because I haven't given it enough information. Anyway, I think that's going to do it for today, folks. So, have a good, if I don't see you again, have a good new year. And we'll leave it at that, and I'll go to sleep and ponder on the best way of doing this conversion till the next time. Catch you again, see you soon. Bye for now, thanks for watching.